Hello and welcome to IP lesson. In this lesson we will continue with securing access. We learned already about the console cable and how to secure the console cable, but let's imagine that our company have more than 22 branches. In that case, if network goes down or network need modification, our network engineer have to travel between the branches in order to fix those issues and to check some configuration at our devices. This is not ideal for our network. For that reason, we can use the remote access protocol. We have two protocols that we can use: SSH and Telnet. Those protocols will give us access to our network equipment even through the internet. So let's start with SSH. SSH stands for Secure Shell. SSH use port 22 at the transport layer, so any data will have a port 22. It will be SSH. SSH encrypts the data, so this means the data will be transmitted securely between our network device and our PC. The second protocol is Telnet. Telnet use port 23, and the Telnet transfers the data in a clear text. So what we mean by transferring the data in a plain text? If we used Telnet between our PC and our network device, the data will be transmitted in a clear text and anyone can see it. For example, if we need to configure our device with username Bob and the password Bob, anyone along the path will see those commands and will be able to read it. Unlike SSH encrypts the data. As we can see in our example, we need to configure our device with username Bob, password Bob. So we will send the data and anyone in the middle will see the data encrypted, similar to that. So no one can understand what is the data we send or we configured our device with, except our device. So this called encryption. So let's take a look at Telnet configuration. In order to configure Telnet, we need to have an IP address for our PC and IP address for the device we are trying to Telnet in. After that, we need to create enable password or enable secret. Then we need to create a username and password. After that, we need to access the line VTY and then choose the method that we are use in order to access our device using the Telnet. So what is VTY? VTY stands for virtual teletype, and when we put the command line VTY, it gives us option to choose how many virtual terminal can access to our device. This means how many sessions we can create to connect to our device at the same time. So the number here start from 0 and we choose 0 to 4, which means we can have 1, 2, 3, 4, 5 sessions at the same time. So let's do the Telnet Lab. In the Telnet Lab, I will use a PC and I will use 3560 switch. I will connect that together and then I will put some notes on my topology. So for my topology, I will use the IP address 1.1.1.0/24. The switch will be with the IP address 1.1.1.1 and my PC will use the IP address 1.1.1.2. Let's configure the PC IP address. IP configuration. The IP address will be 1.1.1.2. Subnet mask will be 255.255.255.0. The default gateway will be the IP address of my switch, which is 1.1.1.1. And for my switch, I will press no. We need to enable routing on my switch in order to be able to operate on layer 3. So I will put the command IP routing. After that, I will enable the interface VLAN 1. Do no shut command in order to turn it on and give it the IP address 1.1.1.1. IP address 1.1.1.1, and the subnet mask will be 255.255.255.0. Let's exit out of the interface subconfiguration mode. I will create enable secret Cisco 123. Then I will create a username and password. Username Bob, password Bob. Then I will enter the line VTY 0 to 4 and then put the command login local. Let's test the telnet from our PC. We can use the command prompt in order to test the telnet. Telnet 1.1.1.1, the IP address of my switch. Now it asks me to put the username and the password. Username Bob, password Bob. Enable. The enable secret is Cisco 123. We can also try to do the telnet from Telnet SSH client. So here I will choose telnet, put the IP address 1.1.1.1, connect. Username is Bob, password is Bob. The next protocol is SSH. In order to configure SSH, we need to have an IP address for our PC and for our switch. After that, we need to create an enable secret, then create a username and password. Since SSH is encrypt the data, it uses an encryption mechanism called public key. We don't need to fully understand the public key right now, but in order to create a public key encryption between our PC and our switch will need a FQDN, something called fully qualified domain name. So in order to create the FQDN for our switch, we need to create a host name and then specify the IP domain. For our example, we create a host name SW1 and the IP domain is iplisten.com. The FQDN will be sw1.iplisten.com and our switch will use that FQDN to generate RSA key. In that key, it will use the FQDN, which is sw1.iplisten.com. The module here will be 2048. I believe that SSH doesn't accept any module below 2048. Next step is to enable SSH version 2. Create a virtual terminal by the command line VTY 04. Specify the logging method. And by default, the virtual terminal use telnet. In that case, we need to specify that we need to use SSH instead, so we can use the command transport input SSH. So now I will configure my switch. First, I will configure the enable secret. Enable secret Cisco 123. Username Bob, password Bob. Now I will change the host name to SW1. Host name SW1. I will create the IP domain name iplisten.com. IP domain / name iplisten.com. Next step, I will create the RSA public key. Crypto key generate RSA. So there is some devices take the whole command at one time. The command is crypto key generate RSA module 2048. But this device doesn't take the whole command at one time. So I will have to type crypto key generate RSA, press enter, and now it asks me if you want to make it 512. I will choose 2048. Press enter and it generates the public key for me. Next step, I will enable the IP SSH version 2. IP SSH version 2. Then I will go to the line VTY 04, line VTY 04. I will specify the login method, which is login local. Login local. Press enter. Next, I am gonna specify that I need to use SSH for the virtual terminal. The command will be transport input SSH. Now let's test SSH. Let's see if we can access our device using SSH. I will click on my PC. Then I will use Telnet SSH client. I will choose SSH. The IP address is 1.1.1.1. The username is Bob. Now it asks me for the password. The password is Bob. And right now I am on the switch. Enable. It asks me for the enable secret, Cisco 123. And right now I have access to my switch using SSH. The next topic that we have is privilege. With privilege, we can assign a privilege to a user, and based on that privilege level, the user will have access to our network equipment. The privilege is from 0 to 15. 0 is the lowest level. 1 allows the user to enter the user exec mode. Privilege 15 is the highest level. And the privilege level from 2 to 14 is a customized level. So we can customize those levels, permit user to access to a specific commands, or prevent user to access to a specific commands. For our example, we can give Bob privilege 15 and we can give Jack privilege 1. Now after we learn about how to secure access using console, Telnet, and SSH, in our examples, we show that we store the username and password on the running config of our device. We can also choose something called AAA server in order to store our credentials on. One of the famous AAA server is Cisco ICE. So what is the benefits of having the Cisco ICE or AAA server to our organization? Let's continue with our example here. In our example, our organization have 22 branch. For traditional network, if we hire a new engineer, in that case we have to go individually to every single device and type the command, the username and the password. This is not ideal for networking. So let's see the benefits of using Cisco ICE or AAA server in our network. So Cisco ICE considered as a NAC solution, network access control, and from the name we can find out that this device is responsible for controlling access to our network. So what we will do for our Cisco ICE, we will configure the username and the password and save all the credentials inside the Cisco ICE instead of going to each device individually and type the username and the password. After that, if there is any request came to our devices, this request will be forwarded to Cisco ICE, and the Cisco ICE will check the credentials inside it, and if it finds the user exists on Cisco ICE credentials, it will permit access to that user. This is the end for this video. If you like my videos, please like, subscribe and share. Thanks for watching and see you in the next one.